Hi, this is Mrs. Often, and tonight we're talking about the distance and midpoint formulas. This is a review of the distance and midpoint formulas, an extension of the distance and midpoint formulas to 3 dimensions, and information on partitioning a segment that has been graphed in the coordinate plane. So our objectives are here. By the end of this slideshow, you will be able to use the distance formula to determine the distance between 2 points plotted in 2 or 3 dimensions. Use the midpoint formula to determine the midpoint of a segment graphed in 2 or 3 dimensions. Given the midpoint and one endpoint of a segment graphed in 2 or 3 dimensions, determine the location of the other endpoint, and our focus is really going to be on 2 dimensions here, and to partition a segment in ways other than bisecting it. So let's get into this. We'll recall from earlier studies that the midpoint of a segment is a point that divides the segment into 2 congruent segments. So if I have my points P, x1, y1, and Q, x2, y2, if the midpoint is the average or the mean of the x coordinates and the mean of the y coordinates. In this example, we see that we have point A, -3, 2. We have point B, 4, -2. These have been substituted into the midpoint formula to get a midpoint of 1/2, 0. And again, I've just taken the mean, the arithmetic mean of the x coordinates and the arithmetic mean of the y coordinates. You can see right here that by visually inspecting, I can verify that my midpoint is in fact 1/2, 0. Similarly, the distance formula is derived from the Pythagorean theorem. I'm taking the horizontal distance between the 2 points and squaring that. So here, -3 to -1. We have a directed distance shown here, that is -4, but when we square that, it becomes +16. I have a vertical distance from 4 to 7, that is 3. That squared is 9. So I end up summing those two together and taking the square root, and I get that my distance is 5. So that's midpoint and distance formula. Now it is possible to find the midpoint of a segment or the distance between 2 points that are located in 3-dimensional space as well. In order to do this, we simply need to add that additional coordinate point, which is the z coordinate. And once we've done that, we're just going to follow the same procedure as we would for the midpoint and distance in 2 dimensions. So you'll notice the distance in 3 dimensions has the x minus x squared, y minus y squared. Now it adds on the z minus z squared. The midpoint in 3 dimensions, similarly, we find the mean of the x coordinates, the mean of the y coordinates, and the mean of the z coordinates. So we're just going to go through an example given the 2 3-dimensional points plotted in space, 5, 12, 10, and 3, 0, -1. So we'll be finding distance and midpoint for those. I'm just going to do distance on one side and midpoint on the other. So the distance I'm going to do the square root of 5 minus 3 squared plus 12 minus 0 squared plus 10 minus -1 squared. So that's going to be 2 squared plus 12 squared plus 11 squared. That's going to be 4 plus 144 is 148. And then that's the square of 11 is 121. So 148 plus 121, that is 269. And And 269, unfortunately, is not a perfect square. I am just going to leave it like this. If you have your calculator, you can determine a decimal value to 2 places. All right, for the midpoint, we're just going to follow the midpoint formula. And the midpoint M will be located at the mean of the x coordinates, the mean of the y coordinates, and the mean of the z coordinates. So 5 plus 3 is 8, divided by 2 is 4, 12 plus 0 is 12, divided by 2 is 6, and 10 plus negative 1 divided by 2 is 9/2. And that would be the midpoint of that segment. So we can obviously extend this into more dimensions if needed, but it doesn't necessarily make sense because we, especially ourselves, will not be working in those higher dimensions. Okay, and so just moving on, I will be erasing this. Something to think about before we move on to partitioning a segment. Suppose you're given the point 0, 0 and asked to provide all the points that are a distance of 4 away from it. So just something to think about here. We might know that 4 on the x-axis, 4 on the y-axis, even -4 on the x and y-axis are all points that are a distance of 4 away from the origin. But are there other points that are a distance of 4 units away? We'll do a little bit of discussion in class, so if you missed that, check back to see the written notes on this. You can also think of the points 1, 2. What would be 5 units away from that? Well, we can go 5 units to the left, 5 units to the right, 5 units up, and 5 units down from the point 1, 2. But are there additional points that make up all points? And something else to think about, what might that entire set look like if it is graphed? So we'll talk about this in class, and looking at the written notes, you will be able to find out some more. Okay, our final example here, partitioning a segment. We need to know the coordinates of the point that are 3/5 of the way from A to B. So I have A at 3, -4 and B 13, 11. I'm going to begin by determining 3/5 of the horizontal and vertical change from A to B. So from A to B, the horizontal change goes from 3 to 13. That is 10 units. My vertical change is 15 units. So I'm going to find 3/5 of each of those. 3/5 of 10 is 6. I'll draw that in blue. And 3/5 of 15 is 9. I'll draw that in blue as well. And you can see that I have a smaller, similar triangle here. And that's going to help me to locate my extra point. So this is 6. This is 9. Since I'm going from A to B, it's going to be easiest for me to find that 3/5 and add it to the x coordinate of A for the horizontal change and the y coordinate of A for the vertical change. So I'm starting at 3, going over 6 to the right. Then from -4, I'm going 9 up. And that's going to translate my point from 3, -4 over to 9, 5. So there's my change. Now, some things to think about. And again, we'll chit-chat about this a little bit in class. What other way could you solve this problem? And how is this similar to or different from finding the midpoint? Well, I hope you found this to be a valuable review and extension of the midpoint and distance formulas. Thanks so much for joining me, and see you in class.